Hello and welcome to this webinar, one of a series by Outokumpu covering a variety of aspects of stainless steel. Today we're going to look at 654 SMO. Please note that the information we give here can only be considered as general guidance, and if you're considering the use of stainless steel, you should discuss your specific requirements and environmental conditions with your local Outokumpu sales office, and they'll be delighted to offer more tailored information. Today, I'm just going to give you a very brief overview of Outokumpu, then I'll talk about 654 SMO from 4 different perspectives. First an introduction, then a technical view, customer view, and then the product range and some fabrication data. So as I said, first of all, a few words about Outokumpu as a group. Outokumpu is a global leader in stainless steel with the vision to become the undisputed #1. We employ some 8,000 people in 30 countries with net sales in 2011 of just over 5 billion euros, and we're listed on the Nasdaq and OMX exchange in Helsinki. Stainless steel can be used in many different applications, from bridges to cutlery, and in architecture, of course, in many industrial uses. There are endless possibilities for stainless steel. Outokumpu has many services to ease your work, and we can provide technical advice and information, help with material selection, corrosion research, advice about design and fabrication, process development, and alloy development, among others. But now I'll turn to our main focus for this presentation and tell you all about Outokumpu's 654 SMO. 654 SMO belongs to a family of high-performance austenitic stainless steels which offers levels of fluoride pitting and crevice corrosion resistance not previously possible with any other stainless steel. And it's these characteristics which make it ideally suited as an alternative to nickel-based alloys and titanium in many applications. 654 SMO is characterized by optimal levels of chromium, molybdenum, and nitrogen. Also, given that it uses less nickel and molybdenum than other nickel-based alloys, it's an extremely cost-efficient and competitive alternative. There are several defining aspects of 654 SMO business case, and first of all, one can look forward to increased reliability because of the enhanced corrosion resistance, and therefore also improved cost efficiency. And because of this superior material properties, one can expect better durability and reduced maintenance. And furthermore, there's better price stability over nickel-based alloys due to the relatively low nickel and molybdenum content, as we mentioned a moment ago. And as we know, it's characterized by outstanding resistance to pitting, crevice, and uniform corrosion. It has a high resistance to stress corrosion cracking, while providing almost twice the strength of common austenitic stainless steels. All this while enjoying high ductility and toughness. And underpinning all of these aspects is the superior knowledge and support you can expect from Outokumpu applied to your unique requirements. If we compare 654 SMO with the nickel alloy, C276, we can see that across the major criteria of pitting and crevice corrosion and mechanical strength, 654 SMO is superior. In uniform corrosion resistance, depending on the environment, it should be similar, as is fabricability. But due to the much lower reliance on nickel, the price stability of 654 SMO is superior, as it's not so much at the mercy of the volatility of the alloy price. Now let's take a look at some more technical information about 654 SMO. Looking at the relative position of this grade compared with other stainless steels and nickel-based alloys. If you look at the chart, which plots the mechanical strength and corrosion resistance, you can see that 654 SMO falls to the right of all the other grades here, and also higher than the nickel-based alloy C276. Also, if we look back to the vertical axis, mechanical strength, we can see that 654 SMO is again superior to the nickel-based alloy C276. And if we look at the values in the table above the chart, where we compare 654 SMO with 276, the most remarkable value to note is, of course, for nickel. Despite 654 SMO having only 22% nickel compared with C276, 57%, 654 SMO provides at least equal and often superior corrosion resistance due to the higher chromium level, as well as the alloying of molybdenum and nitrogen. So let's turn now to the corrosion indicators of the PRE and CPT values. You can see from this chart that we've plotted 654 SMO against a wide range of other stainless steels, and you can see that 654 SMO offers superior PRE and CPT performance to any other material we supply. We also have other important corrosion indicators such as CCT tests, and again, as these charts show, 654 SMO offers superior performance to other stainless steels as well as the alloy of C276. Now, in an example of a 654 SMO used in plate heat exchanger, this was a test carried out in seawater with a salinity of 3.3 to 3.6%, tested across a range of temperatures and for a period of more than 3 months. The outcome was quite clear. While 254 SMO suffered crevice corrosion at 45 degrees and C276 suffered shallow crevice corrosion at 45 degrees C, 654 SMO was resistant to crevice corrosion at 70 degrees C. Looking at other stress corrosion tests, we can see that Outokumpu 654 SMO is superior or on a par with the other stainless steels or nickel-based alloys. Turning away from the technical aspects, let's now look at some customer views of this remarkable alloy, where it's been used as an alternative to the other grades or indeed nickel-based alloys. And on this slide, you can see an example of where it's been used in flow lines which transfer crude oil from offshore wells to the surface of the sea. This is an environment where we find high levels of corrosion due to the sea and other factors, high temperatures, as well as significant pressures. These flow lines have traditionally been married with super martensitic 13 chromium steel grades up to nickel-based cladding material. In this case, 654 SMO can be a cost-efficient alternative. And as already mentioned, 654 SMO can be an alternative in plate and spiral heat exchangers, where we can benefit from the exceptional mechanical and physical properties of 654 SMO. Properties which are very useful when pressing complex heat exchanger plates from thin sheet, for example. But also, the high corrosion resistant to chemical products and seawater of 654 SMO would suggest that it can be an extremely cost-effective solution for a wide range of plate and spiral heat exchanger applications. Another application where 654 SMO seems well suited is flue gas cleaning. This is an environment where we find high temperatures as well as high acid and high chloride levels present. And we'll see that the superior corrosion resistant characteristics of 654 SMO demonstrated to the full. Again, compared with nickel-based alloys, the price stability of 654 SMO provides a clear advantage, and when compared with the coated concrete and GRP lower life cycle and maintenance costs are obvious. Another application area for 654 SMO is condenser tubes, and it's been used in Swedish and Finnish nuclear power plants to replace titanium in the most aggressive areas. And due to the high corrosion resistance, it's ideally suited to applications with fresh or seawater across a wide range of temperatures. Yet another area where we expect to see increasing use of 654 SMO is in the filters for off-gas handling systems, where the condensate is formed when cleaning sulfur-bearing gases from smelters or power systems. And with a very high mechanical strength, it's also very resistant to the wear from particles carried in the gas, which is also very important. Seawater cooling systems not only have to endure the corrosive nature of seawater itself, but also the variety of additions introduced into the system. And 654 SMO can often be the answer to these challenges. As with all the other grades that Outokumpu manufactures, we can also provide specific advice and technical support on fabrication with 654 SMO, from hot forming to cold forming, machining, heat treatment and welding. I won't dwell on the detail here other than to point out that there's nothing too special about welding 654 SMO, for example, and that it uses conventional methods employed with common austenitic grades. In terms of the product forms, the range, in terms of the product forms, the range for 654 SMO will be more narrowly focused than customers might expect with the more mainstream grades. We've got material available in plate, hot rolled quarto plate, which will be from 8 to 20 millimeters thick, but also from 4.75 to 50 millimeters on request. We can provide cold rolled coil sheets and plates from 0.5 to 3 millimeters thick, and then we have cold rolled coil and strip in bright annealed, BA, which is 0.25 to 1 millimeters thick. Complementing this range of flat product, there are also some tubes and pipes available in some commonly required dimensions. When specifying 654 SMO, it's obviously very important to know that it's recognized in many different standards, and on this table you can see a number of international standards where 654 SMO is already present. And we also have a cold case in ASME for use in pressure vessels. So let me summarize 654 SMO and its significant benefits. It has outstanding resistance to pitting crevice and uniform corrosion. It's got very high resistance to stress, corrosion, cracking. It's almost twice the strength of common austenitic stainless steels. It's got excellent formability, very good resistance to erosion and wear, good ductility and darkness. Price stability is extremely good. And then you have the industry-leading technical support from Outokumpu, all of which means it can be an excellent alternative to nickel-based alloys and titanium grades. So thank you very much for your attention. Hope you've enjoyed it, and we look forward to receiving any of your questions on the address shown on this slide. Thank you and goodbye.